is this relationship proportional? Is the table proportional, really? And we can figure this out pretty quick just by looking at the y's and x values on this. Remember, proportional relationships, we're going to be comparing y values in the numerators and x values in the denominators. So it's a y to x ratio. And so for these ones, that's pretty much all we're going to be doing. Okay, so I'll start with the first line here, which is 1, 5. That would be the ordered pair, which you could write it as an ordered pair if you'd like. Not that I think you care, but remember all our y values will be in the numerator. So I see the y value is 5, and all our x values will be in the denominator. So it's 5 over 1, which simplifies to just 5. Okay, now just having one ordered pair is not enough to determine proportionality, but 2 or more, yeah, then we can determine proportionality. So for the next set, we know that here the y value is 10, so that's going to be the numerator, and the x value is 2, so it's 10 divided by 2, which gives us 5. So these two values are still the same, which means that at least between these two, they're proportional, but we now need to check the third ordered pair as a fraction, where the y value is 40 and the x value is 8. And 40 divided by 8, you can put that in the calculator, you still get 5 right there, okay? So, we see now that the values, or the ratios, I guess I should say ratios of y to x are all the same. So this table is proportional, okay? Now, just a little bit about what we talked about last time is, since these are proportional, you can find what we call a proportional constant. And if you were looking for it, that's the 5s right here. Okay, these are all proportional constant, the proportional constant. And I bring that up because today we're going to be dealing a lot with the proportional constant, and not only being able to determine what it is from a table, but today it's going to have a little bit to do with equations also. So here's our two objectives for today. I can write proportional equations. So this will be the first time we've seen that because we did not see them last time. And also we need to be able to interpret and also identify constants of proportionality. We did do some interpretation of constants of proportionality in the last lesson, but we'll do a little bit more today as well. So take 15 seconds and copy this down. So, writing a proportional equation, we have this type of equation right here, but let's go back, okay? So when we talk about equations should have equal signs like this. Now remember, equal signs are conditional statements, and the question with equal signs, which we've seen quite a bit of, is if we're looking at true or false type situations, okay? Because it's possible you could have a number like 10 and compare it with a number like 4. The problem with this is that now you're looking at a situation that is false, okay? We're looking for only true statements when we look at equations. The problem is if we say that we have different variables, okay? So we've seen variables in equations before, and we'll look at something that makes it true. But it's possible to compare different letters like y's and x's like this, okay? So right here, if we say that y equals x, then if I said for some reason y equals 8, then x would also have to be 8. So that, and you could write that as an ordered pair if you wanted to, not that I think you would, but you could. 8, 8. Well, why is this significant? Because is 8 the only value that would make this true? No, if I change these values, I could still find a true statement, but it still correlates with what we would look at as 8, 8. So you could have said, well, y equals -2. And then if that was the case, then x would have to be -2 in order for this, again, we're looking for it to be true. So then we get this ordered pair, -2, -2, okay? But there's an infinite number of ordered pairs that would make this true. And in fact, the x and y value are represented from ordered pairs, okay? So when we see equations like this, it means that you can replace x's and y's with numbers, but we're looking to make the equal sign a true statement. So let's go back to the slide here, okay? So we got writing a proportional equation. first thing we want to do is find the constant of proportionality. If we remember, which hopefully we do, just like we saw in the bell work, it's the unit rate. Okay? Now, as soon as we find that unit rate or constant of proportionality, all we're doing is fitting it in as the coefficient of x. Remember, the coefficient of x is the number multiplied. Usually it's just by the letter, but in this case, it's specifically talking about the x. Okay? So it's the number multiplied by x. So when we write our equations, we'll still use the same letters, y, well, most of the time anyways. Y's and x's like this. It's just, there's kind of like a blank right here that we're going to fill in as our constant of proportionality. That's where that goes. So, for example, on the bell work, we could write an equation for that table. We'd say y equals, we knew the constant of proportionality was 5, so we just fit in 5 right there, okay? Now, along these lines, just being able to enter these into the assignment could prove a little bit tricky. Because what they want is a multiplication sign between, in this case, the 5 and the x right there. And to access the multiplication sign, it's just an asterisk. So you just push Shift 8, and then it will give you the multiplication sign right there, okay? Now, all x values and corresponding y values must make the equation true, which we talked about extensively so far. So I'll keep that there for now, and then hopefully we can see that in some of the examples we do. Maybe not. Whatever the case is, down here at the bottom, we see that x values are what we call independent variables, and y's are what we call dependent variables. And we can usually determine pretty quickly which one's independent and dependent just by asking one simple question, which label, I guess you could say, depends, and that's one of the key words, on the other. Okay, and as soon as you determine which one that is, then you know which one is dependent. Okay. Now that may take several readings and rereadings before you can make that determination. The reason why we need to know that is so that when we go to write our equations, we know which value is x and which one is y as well. Okay. Also, the equation that we have written, this equation is written in for y in terms of x. That'll be important for us to remember because they're going to use that type of terminology in some of these word problems that we're going to see. All right? Here's our first example. Anna buys 8 bottles of pineapple juice at the corner store for a total cost of $4.72. Assume each bottle of juice is the same price. If C represents the total cost in dollars and cents of the juice for any number J of bottles of juice, write a proportional equation for C in terms of J that matches the context. So we're looking at C in terms of J right here at the bottom. That'd be important for us. C in terms of J. So remember, just like we saw on that last slide, so I'll write this out again. C in terms of J. But we want our equations written usually y in terms of x. Now, why am I stating this? It's because this tells us that for our equation that we'll be writing for this one, because that's what it said it wanted, it wants the proportional equation for this. And it should look something like this, right? So we got y equals m times whatever the x is. Put the multiplication in there. It's just this time, instead of using a y, over here we can see that they're using a c instead. Or instead of an x, they're using a j. So I would say instead of an x, I now have a j. But again, here we need to figure out what that constant of proportionality is so we can fill in this blank. So let's do that. Okay, so the constant of proportionality can be found fairly quickly because all we're going to do is take a y value and divide it by an x value, right? Y's divided by x. And we can see over here, just from what we discovered, the y's are c, that's the cost. And up here, we see that the cost is $4.72. So that's going to be my numerator, $4.72, that's cost. And then our x's, right, that's j, that's bottles of juice. We'll just say bottles, 8 bottles. But remember, our constant of proportionality is a unit rate. So in the end here, we need to determine this for one bottle. How many dollars this would be for one bottle? So all I'm going to do is take my calculator, and I'm actually going to type in 4.72 divided by 8. And when I push enter, this will tell me how many dollars that is for one bottle. That's 0.59 or 59 cents for every bottle. And that right there is my constant of proportionality, okay? Now, I don't have to put this in as a rate. I don't have to put it in with labels because of the equation. All I'm going to do is put that in as the decimal, okay? So 0.59. Now, this should make sense, by the way, and that's actually our answer right there. This should make sense to us because it's 59 cents for every bottle. That's the discovery we made with the unit rate, and the unit rate is the constant of proportionality. But it's 59 cents per bottle, so if you multiply that by however many bottles, like let's say you purchased 100 bottles, right? Then it'd be 59 cents times 100 bottles, and that would tell you the cost, which in that case would be 59 bucks. But this is what an equation allows us to do. It allows us to say, in this equation, let's say you purchase 100 bottles, then the cost would be 59 bucks, okay? Or if you wanted to purchase 10 bottles, then it'd be $5.90. And there's lots of different ways to express that. Throw that at me, please. There's an infinite number of ordered pairs that would make this true, but this is just two that would do that for us. Now, in relationship to dependent and independent variables, on this one we can see that the cost is going to depend on how many juice bottles you purchase, which is why the cost here is representative of the Y, and the juice bottles is independent, so that it is the X's. All right, for this one, Nicole practices the piano 1,008 minutes in 8 weeks. If T represents the total time she practices for any number of days, D, right? A proportional equation for T in terms of D that matches this context. Fair enough. Okay, so, but they did tell us down here, T in terms of D, remember, it's always Y in terms of X, okay? So we want this so that we can understand which is which. And right here, we can see that the T's are the Y's. So for our equation, Y equals MX, instead of using a Y here, we're using a T. And instead of using an X, like we see here, we're using a D instead. Now the M is always going to be replaced by some kind of numerical value, which we'll find. So let's find out what that is. But again, the M, well, that's our constant of proportionality. So let's go ahead and figure out what that is. Okay, well, it's going to be shown as a fraction. And we got two different values here. But we know that the T, which says that was a time she practices, the practice time depends on how many days have passed. So for our constant of proportionality, we got T in the numerators and D's in the denominator. So it says up here that she practiced for 1,008 minutes. So we're going to put 1,008 in as our numerator. And I'll even label that so we know that it's in minutes. And it's for 8 weeks. Now, the problem with this 8 weeks is that down here it says it wants days. So I'm going to figure out how many days that is by taking my 8 weeks. I know there's 7 days in a week, so I'm just going to multiply that by 7, and that tells me that 8 weeks is the same as 56 days. So I almost made this mistake in the last class, but don't put an 8 right here because it's 8 weeks. D is for days. You got to figure out how many days are in 8 weeks, which we just found as 56 days. Now, that's not exactly our constant of proportionality. We want to figure out exactly what that is by actually dividing those two values. But the labels will still be the same. We've got minutes in the numerator and then days in the denominator. So let's figure out what that is. 1,008 divided by 56. In my calculator, it tells me it's 18 minutes for every 1 day. Okay, so that is our unit rate, which is the constant of proportionality. I do not need to show that as a fraction like we are right here. All I'm going to do is put in 18, and that's it. That's the equation that we want. Now, keep in mind on the assignment There are some times where it just has a box right here for 18, so you just type in 18 and then you push enter. Sometimes it will want you to show that 18 times d, so you may have to put that multiplication sign between the d. And then really this is all you'd have to type in. In some of the problems you have to type in the full equation, t equals 18 times d, and then it will give you full credit, okay? But be aware that it may ask for different things, and it may ask you to input different ways for this equation, but they all pretty much mean the same thing. This table shows your earnings for a job. If E represents, I guess, your total earnings in dollars and cents for any number of hours worked, H, write a proportional equation for E in terms of H that matches the context. You guys take a minute, see if you can do this one, and we'll go over it together, okay? So, on this one, there's a couple of things just in the wording that they gave us. It says that we're going to write a proportional equation, which allows us to assume that the table is already proportional. Now, whether you assume that or not, we can actually confirm it by just taking each of these y values and dividing them by the x values. But that's the other thing, before I get to that, is this table actually tells us which values are y's and which ones are x's. Remember that x's are the left column, and then y's are the right column right here, okay? So that tells me that I know that y, which is dependent, that's the earnings, and x, that's our independent variable, which is the time in hours. In other words, the amount of money that you'll earn from whatever job this is will depend on how many hours you work. Okay, independent and dependent. We could have made that determination as well down here where it says E in terms of H, remembering that Y in terms of X, that's the way this is always going to be written. Okay, so I can see right here that my E is going to be my Y's, and then the H will represent the X's for the equation. So remember our equation, it's going to look like this: Y equals mx, or m times x. It's just, again, instead of a y, we're using an e, and instead of an x, we're using an h. So we get e equals something times h. We just got to figure out what that something is. That's our constant of proportionality. That is our unit rate. So over here, without having to show the work, because I hope you guys had enough time to do that, I did in my calculator 1,310.58 divided by 18, and it gave me 72.81. In fact, it did the same thing for these other two as well, okay? So this was just to prove that the table actually is proportional by taking my earnings divided by hours all 3 times. So they are the same, which, again, that would just prove that it's proportional. But again, that 72.81, that is actually our constant of proportionality. Okay? So since that's our constant of proportionality, we know where that goes. That's the coefficient of, in this case, h. So instead of m there, we're going to have a 72.81. And this right here would represent that equation. Now, just to specify what equations mean, this means that if you took the earnings and their corresponding hours and plug all 3 of these into this equation, you would get a true statement, which is what we do want. The constant of proportionality on this one could be interpreted, since we know it's y's to x's, and the y's in this case is the earnings. I could just label this in dollars, and then I know it's per or for every, in this case, 1 hour. And again, this would be an interpretation of the constant of proportionality. All right, identifying the constant of proportionality in the equations. So we've already interpreted them in the examples. So just identifying where it is in the equation, though, that's the key point. We're looking for y equals mx, or m times x, really. Now, if it ever comes in this format, m is the coefficient of x. So that's important to remember. And we've seen quite a bit of that already. Okay, so in the first equation we saw today, y equals, just from the table, from the bell work, it was y equals 5x. If it said, hey, find the constant of proportionality on that one, it would be the 5. Okay, it's not the x is not included. The x is a variable. the y is a variable as well. All we're looking for is the 5, that's it. Okay, so whenever you see an equation, and it could be like that last equation. So this last equation we saw, if it said, hey, go ahead and find that constant of proportionality, well, it's right there, 72.81, okay? So being able to not just be able to find them from the situations, but then if it gives us an equation, we need to be able to do that as well on the assignment. In fact, sometimes it'll say, instead of or constant of proportionality, it may say something like scale factor. We haven't gone over scale factors, though we will in a later unit. But just keep that in mind for the assignment. So let's read this extraordinarily long word problem. The proportional relationship between the number of sweaters a clothing store buys and sells, S, and the profit in dollars and cents that it makes off those sweaters can be represented by the equation P. So I guess that's profit equals 23S. S, remember that's sweaters. What is the profit in dollars and cents that the store makes per sweater? So it says right here, okay, we're looking for the profit per sweater, and so that's actually asking for dollars per one sweater. Okay, hopefully remember that, which tells us that this right here, it's asking actually for the unit rate, which simultaneously means that they're asking for the constant of proportionality. Well, did they ever give us the constant of proportionality? They sure did. It's the coefficient of, in this case, S, right? Because this equation would have been y equals mx. But now instead of a y, they got a p. Instead of an x, they got an s. But I know that the coefficient of x there, or in this case s, is our constant of proportionality. So 23, boom. Okay. So 23, well, they already told us what this represents, right? It's dollars. So I'm going to make that $23, and then we'll say per one sweater. Now, just to go back to the independent-dependent thing, hopefully this makes sense. The cost that you're going to be charged will depend on how many sweaters you get. So that helps us to understand why the dollars here depends on the number of sweaters, because the more sweaters you buy, the more it will cost. The less sweaters you buy, the less it will cost. And then that's what we end up with right there, okay? What questions are there? Now there's our objective. I can write proportional equations, and also I can interpret constants of proportionality, but also we also looked at being able to identify where constants of proportionality are in proportional equations.